Welcome back to 10.2, day 2. The learning target for this part of 10.2 notes is that you can find the sums of n terms of an arithmetic series. In the previous lesson, 10.1, we looked at finding the nth terms of arithmetic means and of arithmetic sequences using explicit and recursive rules. So today we're looking at arithmetic series, which is the indicated sum of an arithmetic sequence. The indicated sum of an arithmetic sequence. Find the indicated sum of each arithmetic series. So we had a sequence, and now they've just put plus signs between each term. We do not know which the middle terms are, so we actually need to find them to add this as of right now. So what we're going to do is figure out what the common difference is by doing 193 minus 211 and double checking 175 minus 193. Negative 18 is the common difference. So I'm going to take 175 and I'm going to add negative 18. I'm going to add negative 18. So my next term is 157, 139, 121, all the way. We could be doing this forever. So what we're going to do is we're actually going to use a shortcut, because you would be doing this a very long time until we get to negative 455. So we're actually going to use the sum, which there's a formula for it. S sub n, this is going to be for the first, starting with the first term. So this is the partial sum of n over 2 times a sub 1 plus a sub n. This is a formula that you're going to use if you're starting with the first term and then going to whatever the final position term is that you want. So let's say I want to do the partial sum of the first 9 terms. S sub 9 would be 9 over 2 times the first term plus the 9th term. I'd only need to know 2 terms to find that. Or you could also, by the way, if I don't want it to be the first term, I can make it another number, but I have to be careful with the value of n then, because this formula depends on that. So we'll take a look at that in a second. N over 2 times a, or times 2 a sub 1 plus n minus 1 times d. That's the other formula we can use to find the sum of the series. Now, with this formula, what's nice about this formula is if I don't want to start at the first term, but let's say I want to start at the 3rd term or the 5th term, then I could put that here and then just put that position number right here. So let's take a look. It looks like this is starting at the first term, and we're going all the way up to negative 455. So we know that d is negative 18. What we really need to figure out is what position this is. So if you remember our formula, a sub n equals a sub 1 plus d times n minus 1. Well, the only thing we don't have is the position n. So we can actually solve this by doing negative 455 and subtracting 211, which is negative 666 equals negative 18 by n minus 1. I'm now going to divide by negative 18 and add 1. 37 plus 1 is 38. So the value of n is 38. So using our explicit formula, a sub n equals a sub 1 plus d times n minus 1, we're able to plug in this term, the first term. We don't know position n, but we do know that that's in position 1, and we know the value of d. So we solved and got the value of n to be 38. So since we're going from the first term to the last, we're actually doing s sub 38. Well, I can use this formula. You want the sum of the 38 terms. Then I need to do 38 over 2. times the first term plus the last term. So 211 plus negative 455. So in my calculator, I do 38 over 2 times 211 minus 455, or plus negative 455, and I get negative 4,636. See if you can find the 19th partial sum of this series. You will have to find the 19th term, but that's easy enough if you know how to do the work from day 1 of 10.2. All right, 19th partial sum. I want S sub 19. That means I actually need the 19th term. So if I do 23 minus negative 19, or 65 minus 23, I get 42 as the value of the common difference. Well, I've got the common difference. That's great. That means A sub n equals A sub 1 plus 42 times n minus 1. And I need the 19th term. So A sub 19 is going to be negative 19, or not negative 19, that's, negative 19 was A sub 1, plus 42 times 19 minus 1. So negative 19 plus 42 times 19 minus 1 is 737. The 19th term is 737. So now that we know what the 19th term is and we know what the first term is, we can find the partial sum. So we're going to do we're doing 19th term. So we're doing 19 over 2 times the first term plus the last term. Negative 19 plus 737. So I have negative 19 plus 737, which is 718 times 19 over 2, which gives me 6,821. Letter C uses sigma notation, but instead of n equals 1 going to 37, they actually have the 23rd term to the 37th. Now, if I didn't know these rules, for that, I could actually find out position 23, 24, 25, all the way to the 37th position, figure out their terms using this explicit rule, and then I could actually generate or add them all together. But for a problem like the last one, where we were doing 38 terms, that would be very painful. And we might be even asked to do something larger than that. So for this one, we are supposed to start our initial position at 23. So there's our explicit rule, which is nice and helpful, because all I have to do is plug the 23 into it. So that'll be 2 times 23 plus 3, which is 49. And then my 37th position, the final term that I'm going to be adding in this series, A sub 37, that is 37, 2 times 37 plus 3, which is 77. Now, we do need to know how many terms away they are, and we have to be careful. Because if I said, hey, you're going to do problems 1 through 10, you'd say, oh, that's 10 problems. If I said you're going to do problems 3 through 10, some of you would say that's 7 problems. But that's 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8 problems. See, the problem is that you're actually taking the 10 and subtracting 3, but you're not including that 3 as a value when you do that. So by doing that, there's 7 terms, but we're actually including this. So when you do subtraction, you need to add 1 to get the actual quantity of numbers back. So when I have position 23 to 37, n will equal 37 minus 23 plus 1. 15. So we're doing this for 15 terms. So we need to do 15 over 2 times 49 plus 77. This is A sub 1. I often call it A sub I, your initial position, and A sub n being your final position. And the same thing here. 2 times a sub 1, that could be a sub I, and n minus, instead of 1, I. So for this particular problem, the I would be 23. This would be 2 times the output at position 23, and this would be 37 minus 23 if I were using this formula. I'm using this partial sum formula for now. So 15 over 2 times 49 plus 77 is 945. Take a moment to pause the video and try letter D. If you did this correctly, then you got a sub 12 to be 33, a sub 18 to be negative 21, the number of terms to be 7. So using this formula, and you can use the other one if you want, this is the one I prefer, but this one is also valid, then I would actually get 7 halves times 33 plus 21, which is 189 for its partial sum. Now, that is finding the partial sum of a series. But sometimes we're actually given the series and asked to write the arithmetic series in sigma notation. So rather than taking the sigma notation and expanding it and adding them up, or taking the sigma notation and using the formula to find the partial sum, we're actually asked to express this. So a couple things we need when we do this. Whoops, I drew the sigma wrong. We need the initial position for the bottom. We need, actually they say K. And then we need N being the final position at top. And we need an explicit, not a recursive, but an explicit rule here that I could take each position and plug it in to get the output. So we are able to do that as long as the series is arithmetic so far, or even quadratic at this point, because we know how to do quadratic. And some of you have already figured out some of the other ones from 10.1. So if I look at this, my common difference is 1 plus 1 plus 1 keeps going all the way up to 7. Well, I could keep going. This is close enough in the pattern that I could keep going to figure out this position number, but I'm going to pretend that it's a crazy high number and I don't want to sit there and use the recursive pattern to figure out the position. So what I'm going to say is negative 1 is my a sub 1, and 7 is my a sub n. I know my common difference is 1, and I need to do n minus the position of this term, which is 1. This is going to allow me to find position n, so I know what the max term in this series is. So I'm going to add 1, which is 8, divide by 1, I get n minus 1, add 1 again, n equals 9. The 7 is the 9th term in the series, and that's what we expect too if we had done this by hand, if we had kept listing them using the recursive pattern. So far, our rule, our sigma notation for this arithmetic series starts at n equals 1 and goes all the way up to n equals 9. So now we've got our lower bound, this is called our lower bound, and our upper bound. This is upper bound, and I is the lower bound. What I don't have yet, but I can easily attain, is the recursive, or not the recursive, the explicit rule. Well, that's easy enough. I have a sub n equals negative 1 times, or plus 1 times n minus 1. So I have the first term plus the common difference times n minus 1. And if I didn't have the first term, let's say I used 1 instead, or perhaps 7 instead, I'd put a 7 here and put position 9 in for n. But we're trying to find the rules, so or actually instead of 1, if I used the term from position 9, I'd put the 9 here instead of the 1. So I can distribute the 1, whatever, negative 1 plus n minus 1. This becomes n minus 2. So our explicit rule, which would be n minus 2. And there's our sigma notation. Our lower bound being position 1, our upper bound being position 9, our explicit rule. Try this for letter B. All right, we have a slight thing with this one, a twist that I did not show you, and I needed to. They've actually told us the lower bound here. The lower bound was given as n equals 1, so n equals 1 is perfect there. Here, you should have gotten your common difference of negative 0.75, but the lower bound is supposed to be 3. So starting from n equals 3. So when I go to find what the negative 2 is, and I'm starting with my 9.25 plus d, negative 0.75, normally this would be n minus 1. It will not be in this case. I am trying to find position n because I don't know its position, but it won't be minus 1 because 9.2 is not the first position of this series. The initial position this is supposed to represent is the third position. Now I know that's a little confusing because you're thinking, well, why don't they show the first two and just tell us to start here? That's not what's happening. This is the third position. They've told us that this number is our lower bound and it's in position 3. So when I solve this, I have negative 2. I'm going to subtract 9.25. I'm going to divide by negative 0.75. And I'm going to add 3. This gives me a value of n equals 18. So for my sigma notation for letter B, this is an 18 up here. And my explicit rule, again, I'm going to have to be careful how I do this. A sub n equals 9.25 plus negative 0.75. Again, it will not be n minus 1. This is position n, and this position is associated with where this term is located. This tells us that this is located at position 3. So I'm going to distribute. I have negative 0.75n. Negative 0.75 times 3 is negative 2.25 with the 9.25. It's going to be 7. So our explicit rule for this is negative 0.75n plus 7. Should probably put a 0 there, but I didn't, and I can't squeeze it in now. So there's our actual answer for letter B. I actually started to do this wrong, probably the way I showed you, and then I looked up and said, wait, they have n equals 3. So I apologize for not pointing that out sooner. I did reference above that this isn't always a 1. It's our initial term, but it's a little confusing the first time you see it. This is from position 3 since n was given as 3. Applying arithmetic formulas. Find a sub n if s sub n is 200. They also give us the value of a sub 1 and the value of n. Well, we're going to come back up to our formulas, which are s sub n equals n over 2 times a sub 1 plus a sub n. This formula requires me to know the value of n and a sub 1 and a sub n to find the partial sum. Or if I already know the partial sum, then I either have to have 2 of these 3. I have to have a n and a sub 1, or n and a sub n, or these 2 to find n. I do have a sub 1 and I have n, so I might be able to use this to find a sub n, because you can only solve for one variable at a time. Our other formula, n over 2 times 2 by a sub 1 plus n minus 1 times d, only requires us to have a sub 1 and n to find the partial sum. So, and I do still also need the common difference though. In the information that's given here, I do not know the common difference, so I can't use this formula. I have to use this formula. They've told me the partial sum is 200, the value of n is 50, and the first term, a sub 1, is 5. All I don't know is the value of a sub n, which is what I'm trying to find. So I'm going to multiply 200 by 2/50ths, 200 times 2 over 50, and I get a value of 8. plus is equal to 5 plus a sub n. Subtract the 5, a sub n is 3. Now, when you look at the next letter, letter B, which I'm going to let you try in a second, you need to look at these formulas and decide which one you should use based on the information you have given. So take a moment to try that problem. Find a sub 1. Well, in this case, I don't know the value of n. Actually, I do know the value of n. It's 20. And I know the sum, right? I know the value of n because that's the partial sum from 1 to 20. That's what that notation means. So I know n equals 20. I know the sum is 1053, 1053. And I know the value of d. The formula I'm going to want to use is this, because I don't even have a sub 1. Or even a sub n, so I can't solve for two variables at once. So on this, I'm going to do 1053, which is the sum, okay, equals 20 over 2, since n is 20, times 2 times a sub 1, plus n minus 1, well again, n is 20, times d, 17/5. Now I just have to solve for a sub 1. So I'm going to multiply by 2 over 20, or 1 over 10. So I get 105.3 equals 2 times a sub 1 plus, that's going to be 19 times 17/5, which when I put that together is 64.6. So now I'm going to subtract the 64.6 from the 105.3. 105.3 minus 64.6, and I get 40.7. Divide by 2 to get 20.35 for the value of a sub 1. So you will need both formulas, because you're not always given enough information to just use this formula. Sometimes you're going to need, in particular this problem, this formula to solve it. So today we looked at finding the sums of n terms of an arithmetic series. We also looked at how to write problems in sigma notation, write each arithmetic series in sigma notation, find the indicated sum of the series using one of those two formulas, and using those two formulas, if we already know the sum, to find either a sub 1 or a sub n. The assignment that will go along with this section of 10.2, day 2, comes from page 605, and it's 39 to 67 odd. Have a great day.